In this video, I'm going to talk to you about reducing interest loans and payments and constructing what's called a loan schedule. A loan schedule is a table that tells you the balance of the loan at any point in time. And the best way to do this is to work through an example. These loan schedules always refer to a compound interest situation. So that's what we're going to look at in our example. The example we'll use will be a loan of $15,000 at an interest rate of 9%, which is compounded monthly, we're going to look at a repayment amount of $153 per month. So in order to construct the payment schedule, we'll have a number of columns in our table. Months, principal, interest, the payment, and the balance. The payment amount will be the same every month. At the beginning of the first month, the payment amount, or the principal, is $15,000. To calculate the interest, we'll use our simple interest formula, which is $15,000 times 0.09. We're calculating the interest for 1 month, so the time will be 1/12. On our calculator, we'll do 15,000 times 0.09 times 1/12, and we get $112.50. The payment amount is $153. Now, to calculate the balance, we're going to start with the principal, the amount we started with. That's $15,000. We're going to add on to that the interest that's been charged, and we're going to take away from that the payment amount, $153. And we'll end up with, on our calculator, 15,000 plus the interest that's been charged minus the amount that we've paid, and we'll get $14,959.50. And that's the amount that will transfer back down as the principal for the beginning of the second month. $14,959.50. So we're just going to repeat the same process. The interest that will be charged over the course of the second month will be $14,959.50 as the principal times the rate, 0.09, that's decimal, and we're calculating the interest over 1 month. So we'll get $112 and 19.6 will round up to 20 cents. Okay, the payment amount will be the same, $153. It'll be $153 all the way through. The balance now will be what we started with, 14,959.50 plus the interest, $112.20 minus our payment amount. So that will be 14,959.50 plus 112.20 minus 153, and we'll end up with 14,918.70 cents. Now, to calculate the balance at the end of the third month, we'll do exactly the same thing. We'll take the balance here at the end of the second, we'll use that as the starting balance, 14,918.70. We'll calculate the interest over 1 month, PIN, so we'll use the starting value here, 14,918.70. We'll multiply by the interest rate as a decimal, and we're calculating the interest for 1 month, so n will be 1 over 12, 14,918.7 times 0.09 times 1/12, and we'll get $111.89. Now, again, the payment amount for the third month will remain the same, $153. The balance will be our starting value, 14,918.70, plus the interest, $111.89, minus the amount that we've actually paid, which is $153. So if we go through and pop all of that into our calculator, 14,918.7 plus $111.89 minus 153, we get $14,877.59. And at this point it's worth just having a look at what's actually happening with this loan. Each month the payment amount is the same, 153, 153, 153. Each month the balance of the loan goes down. It doesn't go down by the full amount of 153 though. Even though we've paid $153, for example, in the first month, the balance of the loan actually only goes down by about $40.50. The reason for that, of course, is that while we've paid $153, we've actually been charged $112.50 interest. So out of that $153, $112.50 is actually paid in interest before we start taking anything off the $15,000 that we've borrowed. So at the end of the first month, we've got this balance here, $14,959.50, and that's what we start the second month with. Now if you have a look at the interest payments, and this is why it's called a reducing interest loan. If you have a look at the interest payments, each month the interest payment, the amount of interest that's charged actually goes down. It reduces. The first month, the interest that's been charged is $112.50. The second month, it's $112.20, so it's 30 cents less. And the third month, it's $111.89. So here it's actually 31 cents less. So the amount of interest that's charged each month reduces over the course of the loan, while the payment amount stays the same each month, and the balance obviously goes down for the course of the loan until we get to zero. So that's constructing a loan schedule. In real life, banks and other finance institutions calculate the loan repayment amount for compound interest loans using quite a complex formula. We're not going to go into that in Maths A. What we will do is we'll show you how to approximate the repayment amount for loans that are compounded monthly using a table from your textbook. So we've got the table which is on page 341, where we've got a whole lot of amounts, payment amounts in here. At the top of the table we've got different terms, so each of these columns represent a different length of loan, 5 years, 10 years, 15 years, and so on. And we've got an interest rate down the left hand column here, 5, 6, 7, 8% interest. So what this table actually tells you is that for a loan that's compounded monthly, because all of these loans are monthly, loans that are compounded monthly. For a loan, for example, compounded monthly at 6%, over 15 years, for example, the payment amount would be $8.44 for every $1,000 that's borrowed. So I'm going to take you through an example of how to calculate the payment amount. Now, in our loan schedule that we've just done, the payment amount was given in the question. But you need to be able to calculate the payment amount using the table from your textbook. In an exam, a table like that would be supplied, and you'll be expected to be able to work out what the payment amount is for a loan that's being compounded monthly. So the steps involved to calculate the payment amount and remember, this is purely for a loan that's compounded monthly. So the steps involved in calculating that payment amount are as follows. The first thing that we need to do is determine what the payment amount per $1,000 borrowed will be, and we do that using the table. So step 1 is use the table, and that's on page 341 of your textbook, to determine the payment amount per $1,000 borrowed. Okay, so for example, if we had a loan that was compounded 8% monthly for 20 years, right, we'd look at our table, we'd find 8%, we'd go across to 20 years, and we'd see that for a loan compounded monthly at 8% for 20 years, the payment amount per $1,000 borrowed would be $8.36. So step 1 is to work out the payment amount per $1,000, and we do that using the table. The second step is to determine how many thousands of dollars have been borrowed. How many $1,000 have been borrowed. And that's a simple matter of taking the principal, the amount borrowed, and dividing it by 1,000. For example, if you borrowed $5,000, then the number of $1,000 borrowed would be 5,000 divided by 1,000, which would be 5. So if we borrowed 5,000, the number of thousands that we borrowed would be 5. And the final step in calculating the payment amount is to multiply. So the payment amount is equal to the payment per $1,000 times the number of thousands borrowed. And that's how you calculate the payment amount. We'll do one example, or we'll do two examples. The first example will be a simple example. So let's say we need to work out the payment amount. What is the payment amount for a $208,000 loan compounded monthly at 12%. Okay, so we're going to follow our steps. Oops, we do need to say that the term of this loan is 15 years. So following our steps, we're going to look at our table in our textbook. We know that the interest rate is 12% and the term of the loan is 15 years. So the amount of the payment per $1,000 borrowed is $12 per month. So step one, the payment per $1,000 borrowed is, from the table, $12. From table. Step two, we need to work out how many thousands of dollars have we actually borrowed. So the number of thousands borrowed is equal to the principal divided by $1,000. So that's 208,000 divided by 1,000, which is obviously 208. So the third step is to calculate the payment amount, and this is a monthly payment amount, and that will be the number of thousands times the payment per thousand. So payment per thousand times number of thousands, which is $12 times 208. So using your calculator, 12 times 208, we get a payment amount of $2,496.80. and these payment amounts are per month. So that's the first example, the simple example of working out what the payment per month is. The second example that we're going to do is slightly more complicated in that we'll have an interest rate which is not shown on the table. It'll be a fraction or a decimal of an interest rate. So let's do exactly the same problem, except in this example, instead of the interest rate being 12%, we'll make it 12.3%. So in order to determine the payment amount, we're going to follow exactly the same steps. It's just that the first step, determining the payment per $1,000 borrowed, is going to be slightly more complicated. First of all, we're going to say the payment for uh, 12% is $12. Now, remember, this example we're doing is an example where we're trying to calculate the payment amount not for 12% but for 12.3%. So we don't want $12, we don't want $12.65, which is the amount that corresponds to 13%. We want somewhere in between these two values. We want 12.3%. So 12% we know is $12, 13% is $12.65. So the difference between 12 and 13% is $12 and $12.65. So what we're going to say there is the difference is 65 cents. Now, if we wanted 12.5%, we could just halve that 65 cents. We get 32.5 cents, and we just add it on to $12. But we don't want 12.5%. We've been asked to calculate the payment amount for 12.3%. So to do that, we're going to take the decimal part, the 0.3, and we're going to work out what 0.3 of 65 cents is. Okay, and to do that, we're just going to multiply 0.3 by 0.65, and we get 19. We get 0.195. Okay, so 0.3 of 65 cents, that's the difference between 12 and 13%, is 19.5 cents, $0.195. So the payment amount for 12.3% will be the $12 plus, that's the amount for the 12%, plus the amount for the 0.3, which is 0.195. So the payment amount per month for an interest rate of 12.3% is $12 and about 19 cents, 19.5 cents. So now we're just going to continue following the steps from the previous example. The number of thousands borrowed will actually be the same. It'll be the principal divided by 1,000, so 208,000. how many thousands does that equal? Obviously, it's 208. So our payment is $12.195 per $1,000 borrowed. We've borrowed 208 thousands, so the payment amount will be it will be 208. That's the number of thousands we've borrowed times 12.195. That's the payment amount per $1,000 borrowed. So on our calculator, we're going to do 12.195 times 208, and we get our payment amount of 2536.56. Okay, so you can see if we compare the payment amount for 12.3% is slightly more than the payment amount we calculated for just 12%. And that's how you calculate a payment amount, a monthly payment amount. For an amount or for a loan compounded monthly with an interest rate that lies somewhere between the values that are specified in the table.